Greeting my data science friends. I'm going to make this short video to talk about section 18.3.5 and this plot that's here. One of the things I want to point out is that this plot has a couple of typos that we'll get to here in a second. So the first thing we have to do is load the data for these Galton heights. So that is way back in chapter 17 and this heredity, right? And so we have to make sure that we have the history data package loaded and the tidyverse package loaded. And of course, if you've been following along with the author, this stuff will be loaded for you. But don't forget that if you've put it away and turned R off, it's possible you'll have to reload these packages. So the first package we have to do is make sure that tidyverse is running. And so tidyverse is going. And then we've got to make sure that my historical data package is running. That's running. And then one of the other packages we have to make sure is running is this magrittr, because that's where that piping command works through. Okay, so then what I'm going to do is copy and paste these things. Paste those into R. Want the seed. Our author used that seed so that the values would be the same in your example as in his example, but I'm not too concerned about that. So now I have this data frame of father and son and their heights. And so I can say, what is the class of this Galton heights? Tells me it's a data frame. And I can look at the head. So the head command in R is just the top of a table or top of a data frame. Oops, Galton. So that tells me the top of it, and then the tail would tell me the bottom of it. So then I can see all of the things. Okay, so then I'm going to plot just the standard plot of the Galton, and this is going to give me a scatter plot, which looks like this. And the first thing I notice is that father is on the x-axis and son is on the y-axis. And when I look at the results from the author, he has the same results, right? Father is on the x-axis and son is on the y-axis. So that's not surprising, because if father is the independent variable and son is the dependent variable, so in other words, the height of the son is dependent on the height of the father. It would make absolutely no sense if the height of the father was dependent on the height of the son. So if the axes were flipped, as son was independent of father, then that would mean that the height of the father is the result of the height of the son, and that would be incorrect. It didn't make any sense, right? The son's height would be dependent on what happens with the father. So this is correct, and this is the picture he has here. So let's talk about the first error that I see in his diagram. So I got to scroll back down to that example and pass the baseball problem to this spot. It's in his example. Here, and you'll notice that he's got this backwards. He's got son as the independent variable and father as the output. So this says that the father's height depends on the son's height, and that's incorrect. So I can tell you why that happened in a minute. I'm guessing why that mistake was made, but that's a typo. And you notice what happened here in the Gplot. This aesthetic was used command. This makes a much nicer plot than just the scatter plot we did. And he put the son first and the father second. So let's do it that way and see what we get. So I put that in R, and again, this would be wrong, so I'm going to change this, and I want to put father as the input and son the output. And then it uses this nice geometric smooth command, and so I want to put that there, and I get the same picture that I had before, but now father is the input and the result is the son, right? So the height of the son is dependent on the father, is the idea, which is the thing that makes sense. So when I put these two plots next to each other, I get, so this is the first one, the father and the son. And then let's take a look at the first way we did it with the plot command. And get the same graph, it's just not as nice, right? Because of this nice ggplot effect, okay? So that's the first typo that I see. The second typo that I see that he has in his textbook here, that's a little bit, you just have to be careful of, is notice how in the brown box, he's put this confidence interval. So if I copied this command with the confidence interval part, that's the whole part. Usually all of this is together. So then when I put that in R and try that, I'm going to get an error because confidence interval is it's not a command, right? So their typo here is this should have had a notation out with the hashtag. So now it works. But again, if I just copied what he did, this would be incorrect. This is saying that the son's height is input and the father's height depends on the son. So that would from what we should do. Okay, so that's the first thing. So let's fix that to make sure we have it the right way, where the father is the input and the son is the output. All right, so the reason that this happens is I'm going to copy this image. I'm going to save it as a PDF onto my desktop. And I want to look at the next line of code in the book. So what this command here, linear model, did, this ln command, did is make a linear model. And look at the order of the linear model. So the order of the linear model puts the words from what we think. It's output y tilde x. So normally speaking, with the AES, the aesthetics command, we put x first and then y. X is the input, y is the output. But when we use the linear model command, we do y depends on x. So that's what this tilde means. So I think that's where our author made the mistake, is they did this part first as they were thinking about it, and this is the output and input, and they sort of mess that up, right, because the order is wrong. So this is the output is the son, the input is the father, and it's backwards from our traditional XY. So they recopied it and put the comma, but this is backwards. This is y in terms of x, and this is x comma y. Okay, so let me show you what that looks like if I did it with the plots. So if I just plotted, I would have this thing of the scatter. And if I wanted to add the linear model, I do fit equals linear model, and I do the y tilde x is the form that I need. So the y in this case is the son, and then tilde the father, right? Now I don't need this part over here, I get rid of this, but I just made that note so that I remember. And so that's my fit line of those things. and the sun's not found. So maybe I need to put name of the thing here. Dalton Heights. Now it works. I forgot to put the name of where I was getting son and father from. Okay, so then what I do is I type this command ab line of fit. And it puts the linear regression line into my data set. And so it draws it across, right? So again, that's where this tilde situation comes. And our textbook author did that, right? So they have the same, right? They have the son the same as we have, son tilde father, son tilde father. And so they have it correctly. But that's incorrect. So I understand the mistake, how that could happen. But the cool thing, though, to take from this is this neat GM point with this GM underscore smooth method linear model. So what's cool is it draws this regression curve, and then it draws the smoothing over the confidence interval for the entire curve, which is great. So when we do it correctly, it looks like this. But of course, I have to put the x is the input is the father, and the output is the son. I get a much nicer looking graph because of this ggplot with this aesthetic feature. All right, I just wanted to point that out. Sometimes there's errors in textbooks, and sometimes you understand why those happen, and sometimes they're harder to find. So I hope this little video gave you an overview of this ab line deal and this linear model fit.